So, hi everyone, and in today's episode, we'll be discussing some important machine learning terminologies like bias, variance, overfitting, and underfitting. And we shall also see how these all are we can just club them together and understand the whole entire concept. So, let's just start with bias. Bias simply means that you are having certain preconceived notions about certain things. It means you are making assumptions. And what are these assumptions actually? They are made by machine learning algorithms just to simplify the problems. Basic example, if I give you, it's linear regression, which makes assumptions just to solve a problem. It tries to fit the data in a form of a line so that there's a linear function. So this linear functions assume certain parameters, which we shall discuss in coming up videos or episodes, I would say. So what happens here, just for an intuitive knowledge, that bias is making assumptions, and assumptions is m- made to simplify the machine learning problems by the algorithm, and this leads to underfitting of the data. Now we shall explore this underfitting in much detail later. Let's come to what happens because of this bias. Now, if the model is biased, then the accuracy of the model suffers. Model is unable to generalize well on the unseen data. Now, what does this mean? This means that the generalization is something which we are looking forward for any model, because generalization means that the model learns the concept well and it can apply the concepts on the unseen data. So, this is what generalization means, that you can solve any unknown problem which just comes to you because you've learned well, because you're doing well. And also, this biased model leads to underfitting. So I can just link in one thing, that okay, underfitting, bias, I can link assumptions. So just keep these three keywords in your mind. Next we will move on to variance. Okay, so what is this variance? The meaning of variance means that it is the spread of the data. Spread of the data means how my data is spread, like the range of my data, the entire domain of my data, like from 0 to 1000 or 0 to millions. So that is the entire value of my variance spread across the mean. Okay, so mean is also important here. So that is what the variance is. Now I come to, how does it affect my data? What happens actually is that in variance, the algorithm learns too well. Now, here it is learning very well, and it learns even the noises and the outliers, what is not required. So, now what happens due to this? The results is that this leads to overfitting of the data. And when the model overfits, the performance of the model suffer. And again, your accuracy also suffers. So, this overfitting of the data, underfitting of the data is because of bias and variance. And now we move on to something, the next concept, that is overfitting. The meaning of overfitting is that it has no definition, but I can just put it like that. An overfit model is having a high variance and low bias. And we have seen high variance, that means the spread across the mean is huge here. The model learns very well and it again is not able to generalize well. Low bias means it is not making much assumptions, right? Okay. Now we move on to solutions for overfitting. Now, since it is learning too well, what you do is you reduce its learning. So, how do you reduce the learning? You reduce model complexity. Now, suppose you're learning from 6, 7 books and it just increases the burden and stress in your brain. So, what do? You just consolidate it and just read one or two books. So, you're reducing the complexity. Apply the same concept with machine learning and in this overfitting of the data. So you reduce model complexity by reducing the number of features, the columns that we have. And what we do is, how do we reduce complexities and the other methods? We shall discuss it in coming up episodes. But as of now, just an intuitive and just an overview of the methods, that we also use regularization techniques here, like ridge, lasso, L1, L2. And we use resampling methods here, like k-fold cross validation for overcoming this overfitting of the data. Now I come to the next one, and that is called underfitting. Now, this underfitting simply means that my model, the data has not been learned well. The model has not learned the patterns or not learned well from this input data. And you can just assume this, like we do not prepare well for the examination and we do not learn from the required material. And when we appear for exams, we are not able to attempt the questions because we have not learned well and not able to apply this learning. So that means that neither we have learned well nor we are able to generalize it or apply our learning. So this leads to underfitting of the data. Examples. So simple meaning is that you're adding more and more features to your data so that it learns well with good examples and can really enlarge, enhance its learning, because bias introduces limitations in your learning. So what happens is the result is that this reduces the high bias and increases the variance. Now, here I will include one more term, that is bias variance trade off, which is often being asked and which is often being referred to as in many of the articles and in questions of the interview, that what is bias variance trade off. So this is nothing but just a one liner, that when when you tend to reduce the variance, the bias tends to increase, and vice versa. So, and then other questions follow, that what is bias, what is variance. So, we've covered this in the entire episode, and this is how you can link it. So, just bias variance trade off is just a one line statement, that if you want to increase bias, you have to reduce variance. And actually there's no balance between the two. Both bias and variance, they are considered as errors, and these errors actually affect the performance of my model. And so I have to deal with them accurately. I have to reduce the bias or variance, whatever is too large. And this all depends on the data set on which we are working. So the data set nature, the characters, the features in which we are working largely determine the bias and variance, and how we are going to deal with it. So this was it for this episode. In the next episode, we shall see some more important podcast episodes. So stay tuned and thanks for listening.